Guys, hope all of us are doing great. In this specific video, we're going to look at the concept of gases exchange and transport. And of course, this is going to entail the exchange of gases between the surface of the alveoli and the blood capillaries, which are adjacent. So in this specific case, I've given two illustrations for this one and this one. And of course, we're going to see that there is going to be a collaborative way between regions of high concentration and partial pressure to regions of low concentration and partial pressure in facilitating this intake of oxygen and outtake of carbon dioxide in this specific order. So therefore, my left image is showing the specific concentration of various gases, and of course this is going to be facilitating the concept of diffusion, and this is a magnified section of this particular part of the alveoli and the blood capillary, as we're going to see. So the overall concept of ensuring this specific concept of gaseous exchange or gas exchange and transport is to ensure that the blood vessels or the capillaries which are running in a dense network around this alveoli are of course able to take in oxygen from the surface of the alveoli across the surface of the alveoli. We said that it is going to consist of a very thin epithelial layer, and of course they are going to ensure the diffusion, the process of diffusion is successful across this specific membrane surface, and then of course there is a diffusion of carbon dioxide from the blood into the surface to ensure exchange. So for this specific exchange of gases to be successful, there is going to be a diffusion gradient, and of course which is going to ensure that as blood flows in, of course there's going to also to be what we, as we mentioned earlier, the gaseous exchange is going to occur between the air and the blood, which is going to be taking place in the alveoli, and carbon dioxide and oxygen are going to diffuse in or out due to this specific concentration or the pressure, of course gradients, as we're going to see later. And of course, we're going to see from the first illustration that there are two sets of numerical figures for the pressure. This millimeters of mercury. So in the incoming or the blood flow that is going to come across the alveoli, we can be able to see that this is blue in color, of course, which is a color code indicating that this air that is or blood that is flowing across the surface of the alveoli in the capillaries. So this is if, of course, the concentration of carbon dioxide is 45 millimeters of mercury against this 40 millimeters of mercury of oxygen, which means this blood is more concentrated in carbon dioxide as compared to oxygen level. So this outer environment, we can be able to see that the carbon dioxide concentration is 40 millimeters of mercury, which basically means that the concentration in the particular surface, which is the surface of the alveoli for carbon dioxide, is less than the concentration of carbon dioxide in blood, and therefore this is going to create a gradient whereby this is going to be a net diffusion of carbon dioxide into the air, of course this specific section of the alveoli. Now if we compare the concentration of oxygen for this specific illustration, then therefore we are going to see that oxygen's concentration is 40 millimeters of mercury, and this is from the incoming blood, and of course the concentration outside is 104 millimeters of mercury. So there is going to be a net division which is going to occur and facilitate the movement of course oxygen into the blood, and of course carbon dioxide is going to diffuse into the atmosphere. So the net movement division of oxygen is going to be into the blood, and therefore ensuring that this particular flow of blood that is going out is going to be rich in oxygen, and therefore we're going to refer to that one as oxygenated blood. So this particular mechanism is going to be continuous, and it's going to facilitate the gas exchange and transport between the blood and the alveoli. So in our next section, we're going to look at various displays, of course, which are going to complement on this, and basically it's going to create for us an overall overview of or an overview of the pathway that the air is going to take from the nostrils into the alveoli or the blood system. So that is it for now, guys. Catch us in our next video as we're going to look at that specific comprehensive pathway. So that is it for now. I'd like to request our members to kindly subscribe and engage us in the comment section for more on this specific topic, and also check for a link of other playlists of videos that we have done on the same, and of course that is going to assist us understand more on various topics that we have done in biology. So that is it. Bye. God bless you. Catch us in our next video.